What if everything you see, every star, every galaxy, every planet is just a tiny fraction of what's actually out there? What if 95% of our universe is made of an invisible something holding galaxies together and a mysterious energy pushing reality itself apart? We're about to journey to the absolute edge of human knowledge to explore the most profound, unsolved mysteries of the cosmos. We'll hunt for the cosmic ghosts that haunt our telescopes, listen for whispers in the dark, and question the fundamental laws of reality. By the end of this, the way you see the universe and our place in it might never be the same. These are the cosmic enigmas that force us to admit that, in the grand scheme of things, we're just getting started. Our first great mystery is all around us, yet we can't see it at all. It's called dark matter. Think about looking at a city skyline at night. You see the lights, but you don't see the steel beams holding the skyscrapers up. Dark matter is the invisible scaffolding of our universe. It doesn't emit light, absorb it, or reflect it, which makes it totally invisible to all of our telescopes. While the stuff we know and love, atoms, stars, you, me, makes up less than 5% of the universe, dark matter accounts for a whopping 27%. In fact, of all the matter in the cosmos, about 85% of it is dark matter. So if we can't see it, how do we know it's there? Gravity. We see its ghostly fingerprints everywhere. When astronomers looked at distant galaxies, they saw the stars on the outer edges spinning so fast they should have been flung off into space, like kids flying off a merry-go-round that's going way too fast. The gravity from the visible stars and gas wasn't nearly strong enough to hold them together. There had to be something else there, a huge amount of invisible mass providing the extra gravitational glue. That something is dark matter. We also see its signature in the oldest light in the universe, the cosmic microwave background. The patterns in this ancient light show the gravitational effects of massive structures that could only have been formed by dark matter. We even see it when entire galaxy clusters collide. In the famous Bullet cluster, the visible gas clouds crash and slow down, but the dark matter, which only interacts with gravity, passes right through like a phantom. For decades, we've been hunting for what this stuff is actually made of. Is it a cloud of undiscovered ghost-like particles passing through us right now? Or something even more exotic? Despite building incredibly sensitive detectors deep underground, we found nothing. Dark matter remains one of the biggest mysteries in science. A cosmic ghost that shapes our universe but refuses to show its face. Next up, we have a mystery that seems to violate all common sense. For most of the 20th century, scientists debated how the universe would end. Would gravity eventually win, pulling everything back into a big crunch? Or would the expansion from the Big Bang just slowly coast to a stop? Then, in the late 1990s, astronomers measuring distant supernovae got the shock of their lives. The expansion of the universe isn't slowing down, it's speeding up. Imagine you toss a ball into the air. You expect it to slow down and fall back. Now imagine that ball suddenly shooting upwards faster and faster into the sky. That's what our universe is doing. The force driving this is what we call dark energy, and it's the undisputed king of the cosmos, making up an incredible 68% of the universe's total energy density. So what is it? The simplest idea is that it's a cosmological constant, an energy woven into the fabric of empty space itself, but no known physics can explain it. It's like a form of anti-gravity, pushing everything apart. For years, we had no credible suspects, but recently, a wild and highly controversial idea has emerged. Some cosmologists are now exploring whether the source of dark energy might be linked to supermassive black holes. They noticed a stunning correlation. The growth of these cosmic monsters seems to perfectly match the calculated expansion of the universe. The theory, which is still very much on the fringe, suggests that as black holes consume matter, they might be generating dark energy. If this idea holds up, it would be a revolution, connecting two of our greatest cosmic mysteries. For now, it remains a tantalizing clue. Our next mystery takes us from the cosmic scale down to the source code of reality itself. Right now, modern physics stands on two pillars: Einstein's general relativity, our theory of gravity for big things like stars and galaxies, and quantum mechanics, our theory for the bizarre world of tiny things like atoms. Both work perfectly in their own domains. The problem? They hate each other. Try to use them in the same place, like inside a black hole or at the instant of the Big Bang, and the math breaks down, spitting out nonsense. It's like having two different instruction manuals for reality written in languages that can't be translated. This is why the holy grail for physicists is a grand unified theory, or a theory of everything, a single elegant framework that unites all the forces of nature. This isn't just about cleaning up equations. A theory like this could finally tell us what happens at the heart of a black hole, what really powered the Big Bang, and maybe even reveal if our universe has hidden dimensions we can't see. It's the ultimate quest to find order in the chaos and read the fundamental rules of our own existence. Now let's shift from the laws of physics to the possibility of life. This brings us to a question that's both simple and deeply unsettling. Where is everybody? Our galaxy, the Milky Way, has up to 400 billion stars. We now know most of them have planets. With so many worlds, many of which are billions of years older than Earth, it seems like life, even intelligent civilization, should be common. Yet when we scan the cosmos, we're met with a profound, deafening silence. This is the Fermi paradox. The possible explanations range from the hopeful to the terrifying. Maybe life is just incredibly rare and we're one of the first. A darker idea is the great filter, the possibility that all advanced civilizations eventually hit a roadblock, like a technology so dangerous it leads to their self-destruction. Then there's the zoo hypothesis, which suggests that advanced aliens are out there, but they've intentionally cordoned us off, observing us from a distance without interfering. We have no proof, but we have had some tantalizing whispers from the dark. In 1977, a radio telescope picked up a powerful 72-second signal. It was so unusual that the astronomer who found it just circled it on the printout and wrote, "Wow." The wow signal has never been heard again, and its source remains a complete mystery. More recently, we've detected things like fast radio bursts, incredibly powerful blasts of energy from deep space. While most scientists now believe these are caused by natural objects like magnetars, these strange signals prove just how many things are shouting in the cosmic dark. Finally, we arrive at the two most fundamental questions of all. Where did we come from and where are we going? First, the beginning. According to our theories, the Big Bang should have created equal amounts of matter and its twin, antimatter. But when matter and antimatter meet, they annihilate each other. If they had been perfectly balanced, the universe today would be empty, nothing but leftover energy. And yet, here we are. Our existence is proof that for every billion pairs of matter and antimatter particles, one extra particle of matter was somehow left over to build everything we see. What caused this tiny, crucial imbalance? We have no idea. Just as our beginning is a mystery, so is our ultimate end. The fate of our universe is tied to dark energy. If dark energy keeps pushing everything apart, it could lead to a big rip. In this scenario, the expansion would become so strong it would tear everything apart. First galaxies, then solar systems, then planets, and finally the very atoms in our bodies. The other possibility is a big freeze. In this quieter but no less final end, the galaxies would fly apart until they disappeared from view, leaving our galaxy an isolated island in an endless dark void. The universe would slowly fade into a cold, empty darkness, its energy spread too thin to support life. Which fate awaits us all depends on the true nature of that mysterious force we call dark energy. These mysteries aren't just puzzles for scientists. They're questions about the very nature of our reality. They show us that the universe is far stranger and more magnificent than we ever imagined. If you love exploring these frontiers with us, subscribe so you don't miss our next journey into the unknown. And I have to ask, which of these mysteries gets to you the most? The invisible scaffolding of dark matter, the runaway universe powered by dark energy, or that deafening cosmic silence? Let me know in the comments. We've stared into the abyss today. We've explored a universe that's almost entirely invisible, a cosmos that's actively tearing itself apart, and a reality running on rules we have yet to fully understand. But here's the beautiful part. The existence of these mysteries isn't a failure. It's an invitation. Each unanswered question is a doorway to a new discovery. It's a chance to turn that feeling of cosmic insignificance into a shared sense of wonder and adventure. The universe is hiding its greatest secrets in plain sight, and the search for answers is the greatest journey of all.